There is a close relationship between confidence intervals and significance tests. Specifically, if a statistic is significantly different from 0 at the 0.05 level, then the 95% confidence interval will not contain 0. All values in the confidence interval are plausible values for the parameter being estimated, whereas values outside the interval are rejected as plausible values for the parameter. In the physician's reactions case study, the 95% confidence interval for the difference between means extends from 2.00 to 11.26. Therefore, any value lower than 2.00 or higher than 11.26 is rejected as a plausible value for the population difference between means. Since 0 is lower than the lower limit of the interval, 2.00, it is rejected as a plausible value, and the test of the null hypothesis that there is no difference between means is significant. It turns out that the p-value is 0.0057. There is a similar relationship between the 99% confidence interval and significance at the 0.01 level. If the 99% interval does not contain 0, then the effect is significant at the 0.01 level. If the interval contains 0, then the effect is not significant at the 0.01 level. Whenever an effect is significant, all values in the confidence interval will be on the same side of 0, either all positive or all negative. Therefore, a significant finding allows the researcher to reach a confident conclusion about the direction of the effect. There are many situations in which it is very unlikely two conditions will have exactly the same population means. For example, it is practically impossible that aspirin and acetaminophen provide exactly the same degree of pain relief. Therefore, even before an experiment comparing their effectiveness is conducted, the researcher knows that the null hypothesis of exactly no difference is false. However, the researcher does not know which drug offers more relief. If a test of the difference is significant, then the direction of the difference is established, because the values in the confidence interval are either all positive or all negative. If the 95% confidence interval contains 0, then the difference will not be significant at the 0.05 level, and the direction of the effect will not be established. Looking at non-significant effects in terms of confidence intervals makes it very clear why the null hypothesis should not be accepted when it is not rejected. Every value in the confidence interval is a plausible value of the parameter. Since 0 is in the interval, it cannot be rejected. However, there is an infinite number of values in the interval, assuming continuous measurement, and none of them can be rejected either.